Okay, so how to figure out R and S on these bicyclic structures. Well, we'll figure out R and S on these bicyclic structures. Figure out, first of all, when you have bridgeheads, figure out the bridgeheads directly on it. Look for the bond that's in front. You can tell the bond that's in front because there's usually a break right there. And that's just showing that this bond right here, the red bond, is the one that's in front. And so the bond that's in front is attached to this carbon, that carbon's in front, so the hydrogen is coming out at you, so you treat that as a wedge. And then you assign priorities, 1, 2, 3. That's an S, thumb goes straight out you. This carbon has a higher priority than this, because chlorine has a higher priority than oxygen. Then you can do the same thing for the back one, except this one, you treat the hydrogen attached to that as a dash. So your thumb should be going into the screen. So that's an R. You do the same thing over here. 1, 2, 3. R chiral center. 1, 2, 3. That's an S chiral center. Okay. Now, if you take a look at this, from figuring out how to figure out the others, it's a good idea to maybe draw the flat structure. So if you look at this from above, think of that then as this ring. Draw that ring in. It's a 7-membered ring. That has 2 chlorines in it. And then between this carbon and this carbon, you have a CH2 bridge. And that's coming up towards your eye, so you think of that as a wedge. The chlorines are going away from your eye, so you think of those as dashes. And then figuring out R and S on these is pretty straightforward. The chlorine is 1, 2, 3. That's an R chiral center. 1, 2, 3. That's an S chiral center. If you're going to figure out R and S on the bridgeheads, when it's drawn flat like this, what you have to remember is that the hydrogens on the bridgeheads are lines. It's just the way it is. And so you get 1, 2, 3. That's an S chiral center. 1, 2, 3. That's an R chiral center. And you can see it matches the above description. Now, if you do this one right here, I highly suggest that you take this molecule and you rotate it. You rotate it so the bridge that you're looking down on doesn't have any substituents on it. So when you rotate these, the chlorines are heading downwards. So just like that. And then when you look down, there's this 7-membered ring again. So you draw a 7-membered ring. And then you have this CH2 bridge again. It's coming at your, towards your eye, like so. And then the two chlorines, like so. And then you can figure out R and S again. 1, 2, 3. That's an S chiral center. 1, 2, 3. It's an R chiral center. And then these are lines. 1, 2, 3. It's an R chiral center. 1, 2, 3. That's an S chiral center. Now, when you're comparing these molecules, you might be able to see it already, but if you rotate this molecule, this flat structure, 180 degrees, you get that molecule right there. So those molecules are the same. The other thing that you can see is these molecules are also mesocompounds. They have a plane of symmetry in them. And you can see that plane of symmetry in the flat structure. If it's a mesocompound, that means the molecules can't be in enantiomers, because mesocompounds do not have enantiomers. That plane of symmetry you can kind of see on the three-dimensional structure. That's the plane of the screen.